Hello. I had some people emailing me about section 10.1 where they were asking about solving systems of equations using the row elimination method that they talk about in the textbook. They do go into 3x3s, 3x4 matrices in the book. I don't ask you to solve any of that size. It's always going to be two equations in two variables. So because of that, I'm only going to focus on examples with those kinds of systems of equations. So if I gave you this system of equation, for example, 2x plus 3y equals -4, 6x plus 9y equals -5, and asked you to find the solution if it exists to this system of equations, well, we would start by making our matrices, our augmented matrix, where you would have 2, 3, -4, then 6, 9, and -5. And where you go from here kind of depends on the numbers that you have. For the numbers that I have here, I wouldn't want to divide this row by 2, for example, to make this a 1, or this row by 6, for example, to make this a 1. Same thing with dividing by 3 or 9. There's not just nice numbers that line up. If I do that division, I'm going to end up getting a fraction, and then I have to carry that fraction throughout the rest of the operations. So what I can do, though, because remember, our goal is to get to an augmented matrix that looks like this, where I've got a number here and a number here, and that would tell me then that x is equal to that number and y is equal to this other number. So I want something that has a 0 under it. So I can mess with this expression here by saying, okay, well, if I take this row here, row 1, and I multiply it by, say, -3, and then I add that to row 2, that doing that is going to make this 6 go away. And so I want to make that what my new row 2 looks like. And so I'm going to write out the operation and then write what my matrix looks like now. Okay, so if I take row 1 and multiply it by -3, well, -3 times 2 is -6, -3 times 3 is -9, -3 times -4 would be 12. My second row is being left alone in this operation, so 6, 9, -5, and I said I want to add them, so I'm going to add those numbers together. So -6 and 6 gives me 0, -9 and 9 gives me another 0, 12 and -5 is going to give me 7. So my new matrix, I did not change this first one at all, says that I have 2, 3, -4, and I also have the row 0, 0, 7. So this is what my matrix looks like now. And so what this matrix is telling me, remember, these values are my x coefficients, these values are y coefficients, and these are what they equal when I add or subtract them to each other. So according to this matrix, if I have 0 times x, for this row right here, it says that 0x plus 0y is equal to 7. Well, 0 times anything is going to be 0, and 0 over here times anything also going to be 0, and they're telling me that that's supposed to equal 7, which means that they're saying that 0 is supposed to equal 7, which is not possible. So that means this thing has no solution. It's an inconsistent system. So let's look at another system. Let's say I gave you -25x minus 3y equals -113, and, sorry, my cat, 10x plus y is equal to 46. Again, I'm going to make my augmented matrix, so I'll have -25, -3, -113, 10, 1, and 46. And again, because of the numbers that I have in each individual row, I'm not going to start this by, say, dividing everything by some number, because it's just going to give me a fraction, and I don't want to work with fractions in the row operations. But I do want to, again, try and hit this goal of having something that looks like this at the end. So if I can make my numbers interact with each other to make one of them go away, I'm going to do that, okay? So what I notice here, and it doesn't have to be this, but what I happen to notice here is that if I were to multiply this 1 by a value of 3 and add it to this -3, that it would make that -3 go away. And that's part of the goal that I was trying to attain when I said that I'm hoping to get to something that looks like this little augmented matrix here. Okay, that's our goal again. So what I'm going to do is go ahead and do that. I'm going to make these two rows interact with each other to create a new, in this case, row 1. So I'm going to say that I want 3 times my second row to be added to my first row to make for me a new first row. And then I'm going to show that operation. So in this operation, I'm not doing any multiplication to row 1. So I'm just going to rewrite row 1, -25, -3, -113. I'm supposed to be multiplying row 2 by 3, so I will do that. 3 times 10 is 30. 3 times 1 is 3. 3 times 46 gives me 138. And I am supposed to be adding those two sets of numbers together. -25 and 30 gives me 5. -3 and 3 gives me 0. -113 and 138, when I add them together, gives me 25. And these values are what are going to be my new row 1, because that's what I said I was going to make them. So now my matrix that I started with here did this row operation, and now my matrix looks like 5, 0, 25, and then the second row is staying as it was originally, 10, 1, and 46. And so I have that 0 that I wanted for my end goal. I don't have this being a 1, but now when I look at my numbers, 5 and 25 are better numbers for division. So I could go ahead and say divide my first row by 5 and make that my new row 1. So I could say row 1 divided by 5 is now going to be my row 1 values. And so I can do that here. 5 divided by 5 is 1. 0 divided by 5, 0. 25 divided by 5 gives me 5. And I didn't do anything to row 2 in that row operation. So now the original matrix, I've done 2 separate row operations, and now it looks like this. So I'm getting closer to my end goal. For my end goal, I don't want this 10 to be a 10. I want it to be a 0. I can make it 0 by multiplying this 1 by 10, or -10, sorry, and adding it to this +10. So I'm going to make that my next row operation. So I'm going to say here, -10 times row 1 plus row 2 is going to be my new row 2. And I'm going to write that down here so I can see what's happening. So -10 times 1 will give me -10. -10 times 0 will be 0. -10 times 5 will be -50. I'm not doing any multiplication to row 2, so I'm just going to rewrite it. 10, 1, and 46. And I said I wanted to add all those values together. -10 plus 10 gives me 0. 0 plus 1 gives me 1. -50 plus 46 gives me -4. And this is my new row 2. And so now my matrix looks like 1, 0, 5, and my new row 2 is 0, 1, -4. So I have met my goal, and again, this is my X column, this is my Y column. So what this tells me is this equation says that X is equal to 5, and y is equal to -4. So my solution here is that ordered pair. I hope that helps. Let me know if you have any more questions.